do like the little prep thing, the part like what is it? Part one and two.
Yeah, I did it.
Okay. Did you have any questions on it, or you just want to jump into the quiz, or what do you think?
I'm pretty good with it. Are you?
I think so. Good enough.
Okay. We'll figure out this
Yeah.
quiz.
All right, let's do the quiz here.
Yeah.
Group meeting. All right, start. Yes. Yours open yet?
Yeah, I got it.
Okay, so number 3, the total area under a density curve must equal 1.
Yep. Under certain circumstances, a density curve can drop below the x-axis. Is that false?
I don't remember, but do you remember that?
I think there was like a rule that said, let me check, that it had to be like above the horizontal axis or something.
Yeah, I remember there was some rule. Let me see. I think you're right.
The density curve always lies on or above the horizontal axis.
Okay, yeah, that makes sense. Okay, so false. A normal density curve is symmetric. Normal density. Is that true?
I think so.
I think that's true. Okay. Huh? Yeah. Okay.
We're on 6.
Yeah, it's number 6.
Following image, to answer question 6 and 7. Which of the following elements of the figure represents the z-score of this image? Let's see.
C. Yep. Which of the following elements of the figure represent the probability that the random variable z will be greater than 1? Greater than 1? Is it B?
I think so, yeah. The probability, yeah, that makes sense.
Yeah, I think so.
Okay. According to that rule, what proportion of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? 1 standard.
68.
Yeah.
Because in 68, 1, 95 is 2, 99.7 is 3.
Yeah.
Okay. All right. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal and blah, 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 blah. Okay. Well, let me pull that thing up real quick. What do you want to go into again, like career-wise?
Physical therapy.
Oh, very cool. What about your
What are you going
husband?
to? He's going into business.
Sweet. Is he almost done? Or are you almost done?
I'm almost done. He has a little bit more.
Okay. Yeah, my wife, she's done this semester, but I got some more too.
Oh, nice. What's your major?
Mine's exercise physiology,
Okay.
individual prep.
So do you just like plug 1 into the z-score?
I think so. Yeah, I'm gonna read it one more time.
Then I'm confused about what it wants.
Let's see. Says blah blah blah. What proportion of the value from this random variable would be between -1 and 1? Give your answer. If the answer was so I think -1 and 1. So don't we just the z-score is -1 and 1, and then just find the area in between them? Is that
I
makes
guess so.
sense?
Yeah.
So -1, 1, the area in between. I have 0.6827.
Same.
And what answers a decimal accurate to 3 decimal places. So
3.
683, 0.683.
Yeah, I think that's what it's asking, right?
I think so, yeah.
Okay.
Okay.
Let's see. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2?
Same thing.
Yeah. I'm always afraid it's like harder than it seems.
I know. I'm always weary, but 0.955?
Yeah.
Same thing. Okay. Suppose a random variable z has a standard normal distribution. Use the applet. What proportion of the values from this random variable between -3 and 3? Oh, this is just it's just that proving that rule, huh? 68, 95. This
Oh,
one's gonna be
yeah.
99, 99, I bet. Yeah, and it is
That makes sense.
99.997. Okay, now I get it because I was like, what's the
Yeah.
point of? It's like it's kind of easy, but I think I see what they're doing. So
Okay.
0.997 then.
Yeah. So we're just like giving the percentages as
Oh,
proportions.
look at
That makes
question
sense.
12. What we predicted.
Nice.
So I think it's just the first. Well, the values match 68, 95, 99.7.
Yeah.
Okay. Okay.
Okay, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body weight. The population mean protein requirement for adults is 0.66 grams, and the population standard deviation is 0.07. Use this information to answer questions 13 to 17. Okay, so what proportion of the population have a protein requirement that is less than 0.60? So we have to like find the z-score like we did for the prep. Is that right?
Yeah, I think so.
Okay.
Because it tells us what the mean 0.66.
So 6.
So we just got to figure out how many standard deviations 0.6 is away from 0.66. Is that what we're doing?
Yes.
So 0.66, and it's 0.6, so it's 0.06 away divided by 0.07. So it's like 0.85? Or,
Yeah.
or
0.857.
0.86? Yeah, do you think that's right?
Yeah. Did you get
So
a
if we,
negative number for that?
um, I did 0.66 subtract 0.6, but yeah, if you probably did it the other way, and I think that's right. That would have been a negative number.
Okay. So
So
negative.
because it is below the mean, so it would be.
That's
So
right.
it's negative 0.857. Okay, it wants to know that is less than that.
Less than the -1, right? So we do like the last
Less?
third, left third. Yeah.
Yeah, what do you get?
0.1957.
Yeah, me too. So we just round it to 0.196.
Yeah. Sounds good.
196. Okay. What proportion of the population have a protein requirement that is more than 0.6? So we just highlight the other two areas now.
Yeah.
0.804.
Yep.
Okay.
All right. What proportion of the population have a protein requirement that is less than 0.7?
So we have to do that thing again.
Yeah. 0.7. I got 0.571.
Yeah, 0.571. 1. Okay, and it wants to know that is less than that, so it just be the two areas on the left, the middle and the left one.
Oh yeah, yeah.
So what do you get?
0.716.
Yeah, me too. Okay. 0.716. Great. Okay. Did you read that one or did I?
I did.
All right. So 16. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. Hint, remember that to find the area between two values, shaded to the left of each equal, you calculate, and then subtract the small area from the larger area. Okay. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. Give your answer as a decimal, accurate to 3 decimal places. So will lie between 0.6 and 0.7.
So do we just have to subtract like our last two answers from each other?
I think so. Yeah. Yeah.
Okay.
Yeah, that makes perfect sense because that would be getting rid of everything below 0.7 and keeping everything in between, or below what, 0.6 and keeping everything in between, all right?
Yeah.
So 0.804.
Or wait, did we?
Oh, well,
Actually, I think would we be subtracting 13 from 15? Because
less than 0.6. Yes, yeah. Wait.
it's because she said the area between shaded to the left of each z-score. So
Yeah, so it'd be so it's gonna be the 0.71 subtract or 15 subtract 13. Is that what you said?
okay, yeah.
Yeah, you're right. Because this 14 is more than, yeah, so we don't want that. So 0.716 subtract. Okay, what did you get?
I got 0.52.
Yeah. I think we have to put a 0 after that. Like,
Ooh, oh yeah, I guess so.
might as well. Let's just carry it out. All right.
Okay, find the 35 percentile for the protein requirement for adults. Okay. I think this is like some math here.
Let me see. Do we use? I can't remember. Do we use that applet thing?
Yeah.
35th percentile for the protein requirements for adults. I have to look back at the reading. I don't remember.
I think we just put in like the areas, like the percentile, like 0.3500.
For the z-score.
For the
Oh, the
area. Like this
area.
time we're
That's
putting in the
right.
area.
That's right. So hold on. Okay. So we gotta do. It wants the 35th. So you put 0.35. What is it asking for? Find the percentile. So is it everything below that?
Yeah. So I think what we have to do is like set up like the equation for the z-score and then like solve for
X.
yeah.
That's right. Okay. Solve for X. So the z-score. The standard deviations on the bottom. The little mu u thing that is the mean, right?
Yes. So 0.66.
So standard deviation 0.7 or 0.07.
Yeah, 0.07.
The mean is 0.6. Did you get an answer yet?
Not yet.
Okay. Not sure if I did that right. That's me.
Okay.
0.35 times.
I got 0.633.
Let me see that. And then I use 0.6. What did you do? I got something different. I'm not sure
Okay.
I'm doing it right.
So I set it up so it's like negative 0.385 equals x minus
Oh, we
0.
want the negative one, huh?
Yeah, I think so, right?
Because
Because
that's the 30. Otherwise, it would be like the, what would that be? 75th percentile.
yeah.
So, okay. So, yeah. So, negative 0.35 times 0.07
Mm-hmm.
plus 0.66.
Yes.
0.636 if we round it. No, that makes sense. You're right. The 80th percentile, same thing, but positive 0.8, right?
What was that?
So this 18 is the same thing, except our 80, we're gonna have a positive.
Oh yeah.
It's not gonna be. Would it be Oh, do you know what? I forgot. I gotta put it in the applet. I gotta put 0.8. Dang it. Oh, do you know what?
What?
Did we use the right z-score? Did we time it by the area? Is that what we're supposed to do?
For these problems?
For that first one, are we supposed to do? We're supposed to do negative 0.385, or is that what you did?
I used that negative 0.385 as the z-score.
Oh, I think I
Yeah.
used 0.35, but it turned out to be the same thing. Close enough.
Okay.
So okay, all right. So we're gonna put in 0.8 at the top, right?
Yeah.
Then we use that positive z-score of 0.842.
Yeah.
0.842 times 0.07 plus 0.66. Did you get an answer?
I got 0.719.
Me too.
Cool.
0.719 rounded. Okay, I think we are correct.
Yeah.
Should we submit it?
Sure.
95?
You missed one? Oh wait.
Did you?
I
Oh,
got 100.
see, I put something different. See, dang it. For 17, I
Oh
forgot to
no, what'd you put?
I forgot to go back and change it because I did the 0.35. I thought I got the same thing. What did you put?
I put 633.
Oh, I put 636.
Oh, you're so close. You should like ask for that point.
Yeah. Oh well, whatever. It's still. It's not like it brought my grade down or anything.
That's true.
Yeah. See, what is it at? Yeah, 97. Whatever. Cool.
Sorry, we'll be more clear in the future.
No, it's fine. I'm not worried about it.
Okay.
All right. Well, I'll see you Tuesday.
Okay, sounds good.
I knew we were gonna Didn't we talk about getting together
Right.
at some point?
Yeah.
When did we even say that?
I think it was like tomorrow.
I don't think I can tomorrow.
Okay, that's fine with me.
Yeah, I just have so much stuff. I have all my tests next week.
Yeah, I
All
have
my
like tests this
classes.
weekend, so.
Yeah, so it's I think I can. Yeah,
Okay.
Well, I think I'll be okay
Yeah,
delaying
me too.
biostats study for a day.
Yeah, that's
So.
like on kind of the bottom of my list. Not really, but okay.
This is being recorded. She's gonna hear
I
that.
know. That's really bad. I mean, it's not, it's like the very top.
You can't come back from that.
Gosh dang it. You just can't post this now. Sorry. We're gonna have to take a 0.
I don't know if she watches the full length thing. That'd be pretty. That'd be a lot of video watching. But
That'd be intense.
if she does, The class is good. Don't worry. Don't
Yeah,
worry, Mr. Cook. We like it. We just
we
have
love it.
more difficult classes that some take precedence when they come together.
There you go. At the moment.
At the moment, yeah.
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 Well, I'm gonna go before
All
I say
right.
anything else.
All right. I'll see you.
Okay, bye.
Bye.